All right, the next segment that we're going to talk about is the tangent. A tangent is either a line or part of a line that intersects a circle at exactly one point. So if this is my circle, anybody that's tangent to the circle would bump into that circle at exactly one point. The next type of angle that we need to take a look at is the angle that's formed by a chord and a tangent. This says it has its vertex on the circle. So if we look at the picture, segment or line TS would be tangent because it touches the circle in exactly one point. QR would be a chord because his endpoints are on the circle. The degree measure of that angle formed when these two guys intersect is found by taking half the measures of the intercepted arc. Now take a look at this. This is kind of neat and it ties back to what we did a couple days ago. Notice that his vertex here, angle 1, has a vertex that's on the circle. And anytime we have a vertex that's on the circle, the degree measure of the angle is always going to be equal to half of the intercepted arc. So the measure of angle 1, his degree measure is going to be equal to half of the arc that he intercepts. Well, the arc that he intercepts going around the circle is from point R to point Q. So half the measure of arc RQ. And likewise, this guy over here on the other side, angle 2, his degree measure is also going to be equal to half of his intercepted arc. Well, his intercepted arc is this arc that starts here at point R, where we're tangent to the circle, and goes all the way through M and over to Q. So the measure of angle 2 is half, and because that's a major arc, it travels more than halfway around the circle, I need to name it using 3 points, R, M, Q. So that's the second big idea for today. All right, so in the first one we've got tangent AC. They want us to find x. The very first thing that I'm always going to do is I'm going to go find the vertex of the angle, because finding the vertex of the angle dictates to me exactly which one of the rules that I'm going to follow up in that chart above. So this guy has his vertex that's on the circle, and because his vertex is on the circle, I know that the degree measure of the angle is going to be equal to half that of the arc. Now I need to go find the arc. Well, this angle extends through this point up here, and it starts here. So the arc is going to be that green arc right there. I don't know his measure, but I do know that all the way around the entire circle has to be 360 degrees. So if this part over here makes up 240, I know that the green arc must make up 120. So now the degree measure of angle x has to be half of the arc that he intercepts, or half of the 120, or in other words, 60 degrees. All right, the next problem I'm going to approach exactly the same way. The very first thing I'm going to look for is the location of that vertex, because the location of the vertex tells me exactly which of the rules I'm going to follow from my table above. His vertex is on the circle, so I know his degree measure is going to have to be half that of the intercepted arc. The problem in this picture is that I don't know any of the arcs. However, I do know that their sum has to be equal to 360 degrees. So I'm going to set up a little equation that should hopefully allow me to solve for y. And you should be solving these as we go along also to get some, number one, some practice, and to check my work and make sure that the computations that I'm doing are correct. So 2 times 72 would give you 144 degrees for this arc over here. I'm going to make him blue. And then the major arc in this picture, the green one, is going to be 3 times 72, or 216 degrees. And looking at the angle, his intercepted arc is going to go all the way around from this side to his vertex. So his degree measure is going to be half of that of the 216 degree arc, or in other words, 108 degrees.